Alright, this is a quick video doing a couple of practice problems solving with Newton's second law and forces of friction, doing those calculations. So let's get started with a couple examples. So let's say, for example, that Ms. Malmos, myself, is pushing a 100 kilogram sofa across her living room at a constant speed with 130 newtons of applied force. What is the coefficient of kinetic friction between the sofa and the floor? So I'm going to get started by listing out my knowns and my unknowns. So let's do that over here. Oops, a little delayed there, huh? Try again here. And maybe do thicker font. Okay. Okay, so what are some of my knowns? I know the mass of the sofa is 100 kilograms. I know that it's going at a constant speed, so that means acceleration is 0 meters per second squared. That also tells me another important bit of information. If it's at a constant speed, that means that the forces acting on the sofa are balanced forces. And I know that the applied force from Ms. Malmos is 130 newtons. Okay, so now let's list all the things that are unknown. And that's probably going to be a much longer list, but you know how it goes. So what do I not know? A lot. I think right off the top of my head, it's sometimes hard to think about the things that you don't know. I know mass. I really don't know any of the forces that are acting on the sofa. So I don't know the force of friction. I don't know gravity, which means I also don't know the normal force. There's probably a lot more that I don't know, but we'll leave it at that. Things will come up and I can always go back and add them. So that's my first step. My second step is drawing a force diagram. So let's start by drawing the sofa as just a point in space. I know that the sofa is going to experience gravity. And since it's not accelerating, it's going to experience a normal force that's equal to gravity. And there's an applied force from Ms. Malmos. I'm just going to assume it's to the right since they didn't tell me otherwise. And since it's balanced, that means friction is going to equal out the applied force. So those two will be equal. So I'm trying to find the coefficient of friction between the sofa and the floor. I guess that's an unknown. So mu k is something I don't know. So I guess let's just start listing the equations that we might need. Well, if I want to find the coefficient of friction, I need the equation that involves the coefficient of kinetic friction. So my kinetic friction equation is that the force of friction is equal to the coefficient times the normal force. Now I don't know that. I don't know that. I don't know anything in that equation. Okay, so I'm going to have to try and figure out some things in this equation. If I knew what gravity was, I'm going to highlight here. If I knew what gravity was, then that would tell me what my normal force is because those are equal. So if I could calculate force of gravity, that's kind of the same thing as me calculating my normal force. So my force of gravity I can calculate by taking my mass times 9.8. So my mass is 100 times 9.8 is going to get me a force of gravity of 980 newtons. So that means that my normal force is also 980 newtons. Nice, nice. Okay, so I know this. My kinetic friction, I would know if I knew applied force because these two are equal, which I do know because that was something that they gave me. 130 newtons of applied force, which means my friction is 130 newtons of applied force. So my force diagram is really helping me out a ton here with figuring out what I know and what I don't know. It's guiding my thought process almost. So now I've got enough information that I could plug into this equation and solve for my missing variable. So I'm going to do just that. So I'm going to plug in 130 for my force of friction. My mu, or my coefficient, is what I'm going to isolate and solve for. and my normal force is 980. So if I want to solve for a variable in an equation, I need to get it all by itself on one side of the equal sign, which means I need to undo what's being done to it. So I can see that my coefficient is being multiplied by 980, so I undo multiplication by dividing by 980, but whatever I do on one side of the equal sign, I got to do on the other side. So I'm going to also divide by 980 on the other side of the equation. This will cancel out, leaving me with just my coefficient all by itself, and then I just need to figure out what's 130 divided by 980. So let's do 130 divided by 980 is 0.132 blah 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 blah. I think I'm just going to round to the hundredth place. That'll be specific enough that we can tell that we did the problem, and not confuse it with maybe a different answer or rounding error. So 0.13 is safely rounded. It's specific enough, but not so specific that I'm wasting my time writing unnecessary digits. So that would be my coefficient of kinetic friction. So let's do another problem. So it looks like this example is the same situation. So if the coefficient of friction was 0, what would the sofa's acceleration be? So I'm going to kind of continue on with this problem here. So my knowns are going to be the same knowns with just a couple of differences. So it's still the same couch that's 100 kilograms, which seems that my applied force is still the same as well. Ms. Malmus is still pushing with 130 newtons of force, but my coefficient is 0 now. So that means mu k is a given and it's 0, which means that my acceleration is not 0 anymore. So that's no longer a known. It's going to accelerate. So let me list my unknowns. I don't know acceleration. That's what I'm going to try and solve for. That's what they're asking me to find. I guess I do know the normal force and all that information from last time. I guess gravity is going to be the same. It'll be 980 newtons, which means normal force will be 980 newtons as well. But my force of friction, I do not know. Or do I? Let me think about this. If I'm just going to continue with the same force diagram, so I'm not going to redraw it, but I am going to think about that force of friction equation. If I know that my coefficient is 0, and I know that this equation needs my coefficient and it needs my normal force, which I've got, I could plug in and solve for friction, right? My friction would just be 0 times 980, which would just be 0. So this sofa is going to feel no friction. That's a known, which kind of explains why the sofa is going to accelerate. It's not going to experience friction. It's going to be kind of like pushing a soda on ice. A sofa on like an ice rink where there's very little to no friction, or like a giant air hockey table where there's no friction, assuming no friction. So that'll help. Okay, so let me draw my force diagram now. I'm organizing my thoughts here. I know gravity, I know normal, and I know that they're balanced. There's no friction, there's only applied. So that means that I can kind of calculate my acceleration with Newton's second law. Let me tell you why. I can figure out my net force from this diagram. My net force is my unbalanced force. The only force that's not balanced is my applied force. So my net force is 130 newtons, which means I'm probably going to be able to use Newton's second law. So there are 3 versions of Newton's second law. If I'm trying to find acceleration, I want the version that's already solved for acceleration. So that is acceleration equals net force divided by mass, which I know net force and I know mass. So I'm going to plug and solve. My net force is 130. My mass is 100, so my acceleration is going to be, Oops, that looks wonky. Let's try again. My acceleration is going to be 1.3 meters per second squared. Perfect. So, that wasn't too bad. Go ahead and try the last one. You can go ahead and pause and unpause when you're ready to check your answer. I'll go through it as soon as you're done. I'm going to assume that if you're watching, you've paused and unpaused. I always feel like I should wait a couple seconds though, just be sure. So I'm going to just do this really quick. A student gives a 12 Newton push to a 6 kilogram pile of books. It's a big pile of books. But the books remain motionless. Makes sense. What is the minimum coefficient of static friction to keep the books from sliding? So I am solving for a coefficient of friction. Coefficient of static friction, to be sure. So let me really quick list what I know. I know that the mass of books is 6 kilograms. I know that the applied force is 12 newtons. And it's motionless, which tells me the acceleration is 0. And it tells me that my forces are balanced. So my unknowns... Let's see, what am I trying to find? I'm trying to find a mu value, a coefficient value, and I don't know gravity, I don't know my weight, they didn't tell me that, which means I don't know my normal force, and I don't know my friction force either. So a lot of unknowns. So let me draw my diagram. So normal and gravity are going to be equal because it's not accelerating, it's motionless, and then applied it's motionless, so applied is going to equal friction. So these are equal. So if I know applied is 12 newtons, then I know my friction is 12 newtons. So perfect, that's one down. If I know mass, I can find gravity by doing 6 times 9.8. That's going to be slightly less than 60. 6 times 9.8 is 58.8. So my force of gravity is 58.8 newtons, which means my normal force is 58.8 newtons. Perfect. 58.8, 58.8 newtons. So now I can solve for mu with my friction equation. So static friction is less than or equal to the coefficient times normal force. So if my static friction is 12 newtons and my normal force is 58.8, I can solve for my mu. All I have to do is get it all by itself. So I can undo what's being done to mu. I'm going to divide by 58.8. So 12 divided by 58.8 gets me 0.20. 4 doesn't round it up, so it's going to stay 0.20. Oops. Oh, geez, I want it to look nice. Perfect. So this means my coefficient can be any value greater than or equal to 0.2. So the minimum value that it can have, the smallest value it can have, is 0.20. So if you got 0.20, then not only did you get it, but you rounded correctly too. So very nice job. So that wraps up these example problems. Hopefully it was enough to get you started on problem solving with Newton's second law and friction equations. Good luck.